Hey, it's Mr. Pomeroy here, and I'm making this video to help students with thinking with mathematical models, Investigation 1. The big ideas in this first investigation are recognizing linear and nonlinear patterns in tables and graphs and using these patterns to make predictions. Throughout this book, students will use tables, graphs, and equations to explain real-life situations. This video is designed to be helpful to students and parents for the first investigation in our book. Feel free to pause the video at any time. Some people like to watch the video before they jump into the problems and the homework, and other people like to do a little bit of the homework and then check as they go. Use this video however it helps you. This video is designed to help with ACE questions 3 through 5 or the homework questions from the first investigation. So once we get to the investigation with the class, all three problems, then it's time for students to apply their knowledge in some homework questions. We call these the ACE questions, and they stand for applications, connections, and extensions. In our case, we assigned questions 3 through 5, which were all application questions that were directly related to the in-class investigation we already completed. So in our homework question, we're still looking at the company that makes things out of steel rods. They make beams and staircase frames. But in this case, we've added another element, one more variable. So now students are introduced to the cost of making these beams, and it's told to them that each rod costs $2.25, and it costs an additional $50 for shipping and handling. Now it's important to note that there is a $2.25 charge for each rod that's needed to make a beam, but the $50 is not for each rod. The $50 is a one-time shipping cost. It doesn't matter if it's a 1-foot beam or a 50-foot beam or a 100-foot beam. The cost to ship it is a standard one-time cost of $50. So now students are asked to complete the table for the cost of beams. And if you'll notice on the table, now we have 3 rows instead of 2. We have the beam length, we have the number of rods, and we have the cost of the beam. Now the number of rods students should already have from their previous work. All they have to do is copy down the data from their other table. But now we're going to add the cost of the beam, and that would go down along here. Once they have that table completed, they're going to make a graph of that data, but it's important to note they're not going to graph all 3 variables. They're going to graph the beam length as their x variable or their independent variable, and the cost as their y variable or their dependent variable. So these 2 rows will be what's on their graph. Then after they've made a table and graph, they're asked to describe the relationship between the beam length and the cost. And then of course they're going to do the same thing for the staircase frames for the next few questions. Question 4 asks students to decide if things are linear or not by looking at the relationship between the independent and dependent variables in various situations. Question 5 asks students to apply their knowledge of tables, graphs, and equations to a new situation. It's similar to the other ones and yet different. They're looking for a pattern. This one relates a platform used for athletes who get awards during athletic competitions. And you can see the pattern under problem 5 where one medalist requires 1 box to stand on, and if there's 2 medalists it requires 3 boxes to make the platform, and for 3 medalists it requires 6. Once again, students are asked to make a table of the data as illustrated here on 5A, and then a graph of the data as illustrated on 5B. And again, as usual in C, they're asked to describe the pattern of change in the table and the graph. On part D, then, they're asked to look at a new situation applied to it, where they're going to run a carpet runner along the front of the platform and then up the stairs. So here students are told that the runner is 10 feet long in the front of the platform, and then it goes up 1 foot and over 2 feet for each step of the platform. And they're asked to use this data to complete a table below. Then students are asked to make a graph of the number of steps, carpet length data, and describe a pattern of change, and then also to compare this pattern to the pattern in the other data. Once students complete ACE questions 3 through 5, then we go over the answers together as a class. Students have a chance to ask questions, and we look for the accuracy of their results. So in this video, I'll briefly go over some of the results, and you can check these from home if you'd like. So we start out by looking at the table in 3A for the cost of the CSP beams. Remember that each rod here it costs $2.25 to make the beam, plus a $50 one-time fee to ship it. So 3 rods rather, at $2.25 plus $50 equals $56.75, and so on, all the way down to, if you had a beam length of 8 feet, it would require 31 rods at $2.25 per rod plus a $50 shipping fee for a cost of $119.75. Now when students graph this, again, some things to look for are, do they have a title on their graph? Are their variables labeled? And is there a reasonable and correct interval along both axes? So they may have a different interval along the dependent variable or the y-axis than was used here, but it should display the same pattern. So we see a linear relationship here in the numbers graphed. And students should also be able to see, either from the table or the graph or both, that as we increase 1 feet in beam length, the total cost of the beam increases by $9. And we do the same thing for the staircase frames, the table being recorded here and the graph being recorded here. And as they look at both the table and the graph, they realize that this is not a linear relationship. In question 4, students decide if a situation is linear or nonlinear, and those results are posted here. In question 5, the results are made in a table and in a graph, and then students are asked to decide if it's linear or not, and it is not a linear relationship, as you can see from the change in this variable here that is not constant, and also from the graph that is not a straight line but curves. And for part D, where they're looking at the carpet for the platforms, we have the information in a table and in a graph once again. And in this case, it is linear. You see a constant rate of change in the table as the second variable increases by 3 each time, and in the graph as it makes a straight or linear relation. Now, hopefully students will also come up with a rule for this. That's a little advanced for this stage of the game, but we hopefully notice that they are seeing a pattern, that the equation or the rule might be that y equals 3x plus 10. In other words, it takes 3 feet of carpet for each stair plus a 10-foot runner. So we don't start at 0, but we would start here at 10, and then we would go up 3 feet of carpet for every 1 step that we were carpeting. And students are, expected to express that in words as well as in math, and so there's a variety of ways to explain that pattern that they see. Well, this concludes our 4th video in our series with Thinking with Mathematical Models. I hope it's been a help to you going through problems 1 through 3 and then the ACE questions as well. Feel free to email me your questions at this email address.